All right, this brings up a good question. So far, our two curves have always been one is on top of the other during an entire interval. What would happen if those two curves crossed? Let's imagine we wanted to find the area between the two curves that we're looking at right now from -2 to +2. If this were the case, what would happen is we'd have a little area here and a little area here. There are many practical applications in which you would want one of these areas to count as a positive area and the other to count as a negative area. There are other applications in which you want to sum up the two areas. That's what we are going to generally do. If we're looking at two areas, we're going to sum them up. Now, in order to find the left area, or the area that I've shaded in left here, what you would have to do is integrate from -2 to 0, noticing that the y equals 1/4 x to the third is on top. Then you'd have to take another integration from 0 to 2, noticing that y equals x is on top during that span. Let's go ahead and do that. Now, so that I'm not ambiguous on what I'm looking for, when I ask you this question, I will say count all areas as positive. That means I want to add these two together and count them both as positive areas. So we're adding up two areas. Again, if I didn't say that, then the question may be a little bit ambiguous, because sometimes people will generally just talk about one area, or maybe they'll count one as positive and the other as negative, or maybe they count both as positive. So to be clear, we're going to count both of those areas as positive, and that's how we'll ask the question in example 3. We want to find the total area between y equals 1/4 x to the third and y equals x on the interval from -2 to 2, and we're going to count all the areas as positive. This is the same graph that I had, the same functions. You can see from -2 up to 0, y equals 1/4 x to the third is on top, and from 0 to 2, y equals x is on top. So let's go and actually set up my integration. I'm going to be integrating that first area, the left-hand area, from -2 to 0. And on the -2 to 0 subinterval, we know that 1/4 x to the third is the function that's on top. We know that y equals x is the function on bottom. Because that just covers one of the sections, we're going to have to add another integration, this time from 0 to +2. In this case, the x is on top, or y equals x is the curve that's on top. And the 1/4 x to the third is underneath. So we're going to have to do two integrations. Some people do these separately. I'm going to do these both at the same time. The antiderivative of this one is going to be x to the fourth times a 1/16. So we're going to get 1/16 times x to the fourth minus 1/2 times x squared. That is going to be from -2 to 0. So I'm going to be plugging in a -2 and a 0. And then I'm going to do something very similar. The antiderivative, or an antiderivative of x, is 1/2 x squared minus 1/16 times x to the fourth. That is going to be evaluated from 2 down to 0. Now we can plug things in. Well, it's going to be nice to plug in 0 because this is a polynomial. If I plug in 0, I end up just getting a 0. Minus, when I plug in -2, let's plug in -2 into that function. I replace each x with a -2. I'm going to let my calculator do the hard work here in simplifying. I'll do that in just a second. Since we have a plus in between here, let's go ahead and plug in 2 and then plug in 0. If I plug in 2, 1/2 times 2 to the 2 minus 1/16 multiplied times 2 to the 4th. Then minus, what would happen if I plugged in a 0? Well, if I plugged in a 0, I would just get 0. Now I can type this into my calculator. I can either use one line or two. Let's see what happens. Here's what I got. When let's just keep it in the same realm. I got 0 minus, when I evaluated this inside, I ended up with a -1 plus, when I evaluated this inside, I ended up with a +1 . Be careful of your positive and negative signs. We are subtracting a -1 and then adding a +1 along with the zeros. And that means this total area is 2. The area that we saw on the previous slide is 2, a nice whole number. So when functions cross, we can see that we just have to add multiple area parts if I want the total area where all of the areas are counted as positive. What I would like you to do is this problem. Find the total area between y equals x squared and y equals 2x on the interval from -1 to 4, and count all the areas that you get between the curves as positive. go ahead, push pause on the video and try that on your own.